My name is Aaron Rosenzweig. I work with Codivis. That means I work with Marco Gonzalez, Dave Avendasora, and the world's fastest Indian, Tom Phillip. Is Travis Cripps here? I don't think so. Travis Cripps wrote the exist qualifier that we have in Wonder, the ERX exist qualifier. I just happened to extend it over the years. What I want to talk today is not just about the exist qualifier. I want to talk about what we love about web objects, and a big part of that is the enterprise object framework. All of us would agree that simplicity is a wonderful thing. If we have a choice between a complex solution and a simple solution, we'll all gravitate toward the simple solution because simple solutions are easy to write, easy to understand, easy to read, easy to debug because there's just not that much that can go wrong. It's simple. Now, when you look at SQL, structured query language, it's kind of beautiful in its own way because you say what you're selecting and you're saying what you want. You're not telling the database how to get it. You're not telling it how to iterate, how to look. You just kind of set it up. But at the same time, it's not how us humans normally think, right? We think in objects. That's an abstraction we understand. If we ask an animal to make a noise, if it happens to be a cat, it will meow. If it's a dog, it will bark, right? We think in objects. We don't naturally think that to get a company, we have to think of all of its attributes and select every single attribute from the SQL. When we want to change the company's name, we don't think about how we're going to insert and what is the name of it. We want to fetch a company, have all of its stuff puff up into a real object. We want to fetch it. We want to modify its name, say save, and we don't want to think about it. We think in objects. That's a human abstraction. So all of what we do with EOF is complex. We have an ORM, object relational mapping. We design an entity modeler, an object to SQL mapping, right? That's complexity. We have to learn that tool. We have to learn how EOF works. We have to learn how to save changes. We have to learn how all this stuff works. That takes some time. Somebody had to write that. Somebody had to debug it. That's complex, right? So that's actually a complex solution, but it buys the simplicity in how we think about things. Day to day, we benefit from that abstraction. It makes our life simpler. We think about that company. We modify its name. We say save. We don't have to worry about it. We change its relationship. We add the relationship. We add an employee. We don't have to think about the foreign keys and how we're going to modify the persistent data store. We just say, do it, and it does it. So with EOF, we get a proprietary query language. It's much like a true object database. There's some out there, right? Object database. We don't use them, but they exist. And what we get when we write our EO qualifiers, we have something that's proprietary. It's not industry standard. It's SQL, structured query language. That's the industry standard. But our EO qualifiers, they're unique, and we learn them because we benefit from them, right? We get major performance gains. Not necessarily that the code is faster to execute, but to write a new app, we build it faster than anybody else. The neat thing about our query language that we saw earlier this morning is that we can hit the database with our EO qualifiers. We can also hit an NS array. We can filter an NS array with that same qualifier. We saw that earlier today. That's one of the beautiful things about EOF. Now here's a problem though. This is a problem I came into maybe 10 years ago or so, that too many relationships are hard. They're easy for us to model. We can add things to them. We can save them. But when we start doing what's almost like data mining with our apps, when users want to have these forms and they want to query in all these different ways, sometimes it's hard to pull out information when we have a too many. You know, how many of you have ever tried to see if a too many relationship is null or if it has a value? Are you able to do it? There's no straightforward solution using what Apple gives us. We can't, if it's a 2-1 relationship, we can say, is it null? Yeah, we can qualify on that. But to say that an NS array going from company to employees, we want to look at that employees relationship. Is there an employee there? Is there not? We don't have a straightforward way of doing that. The other problem with too many relationships is that they can often have so many SQL joins, and when you're making complex queries, it can be slow to execute. It's also possible, and this is the thing that bit me so many years ago, and it made me sad. I cried. That when you use what Apple gives us to create qualifiers, you can actually make something that you get no results back. I'm going to show that to you in a second. You would think that you get results when you hit the database, but you get nothing back. Now, you can always bring all of your objects up into RAM, right? And then you can do a qualifier in RAM, and that will always work. But what if you have millions of records? Are you going to have that much RAM? Or even if you have that much RAM, you're going to wait for all that to come out? It's very inefficient. I mean, why do you even need a database if that's what you're doing, right? You can just have a text file, bring everything up, make them objects. Why do that? So 2-1 relationships are normally easy, but sometimes they can be slow. 2-1 relationships can be slow when we have some immense joins that have to happen. And in that case, we can actually use an exist qualifier. Normally, I want you to have your head on thinking that exist qualifiers are solving too many problems, but they can also solve 2-1 relationship problems. So the solution is to use the ERX exist qualifier with Codovus improvements. We've been making numerous improvements to the qualifier. Well, one thing is that just by adding an extra parameter to your exist qualifier, you can convert it to an in. Exists and in, they have the same meaning. They're semantically the same. But the performance can be actually very different. And just by setting a Boolean switch, you can make it go either way, exists or in. Our improvements handle much more complex inner qualifiers. I think the original one only handled like maybe 3 inner joins. Ours goes up to like 9 inner joins. And if you need more, it's possible we can extend it further. Our qualifier, the way we've improved it, is that it works in memory. I mean, what's the point of having a qualifier if you have to think about, I can only do this if I'm hitting the database. I can't filter it against an NS array. Now, I understand when Travis made it that he probably said, I'm going to do these certain things when I have in-memory, and what I really care about is hitting the database and hitting it efficiently, fast. And he didn't take the time to write the part to make it in-memory. We added the part to make it in-memory. That was the easier part. But that way you don't have to do this you don't have to think. It works no matter where you're doing it, hitting the database or filtering an NS array. We can handle much longer key paths. When Travis had it, you can only do one hop. Ours can go infinitely long. You have a really long key path, and it will handle that. There's other bug fixes, including issues with Postgres and stuff that we've addressed. So to start off, I want to have a simple entity model. I want to have company. That's one table in the database. And it's going to have a too-many relationship to employee, and the employees are going to have a 2-1 relationship to profession. We all wear many hats, but in this discussion, an employee can only be a chef, a nurse, a computer scientist. He can't be all of those things, only one. And this is what our data is going to look like. We're going to have a company called Joe's Crab Shack. They have one chef, one manager, and a waiter. There's code mongers. They have 3 computer scientists and 1 famous chef. The chef is employed to keep the programmers well-fed and happy and working late hours. We have nobody incorporated that has no employees. This is our data set. Suppose we want to find all companies that have at least 1 chef. Now what we're using here is the ERX keys. Now, if some of us are old hats, what we would do is we would say new EO key value qualifier, we would give the path, and we would set up the type of qualifier. We would say EO qualifier dot operator contains, EO qualifier dot operator equals. Okay? But if you buy into everything that we get with Wonder, when we create our EOs, they automatically have a company dot employees. And that's an ERX key, and we can chain them together. So we can say company.employees, employees where profession, where we have a profession that is a chef. And I don't know about you, if you haven't been doing this lately, it takes a little bit to get your head around it, but you can see how nice and expressive it is. And this really is like a custom proprietary query language, right? but we get a lot of benefit. It's easy to read, easy to write. And then all we do is, now that we have a qualifier that builds up a qualifier that tries to find all of the companies that have at least one chef. And we just say fetch. Ken, what's wrong with this?
I haven't looked at it.
Steve from Toronto, are you in the room? Steve? No, he's not. Okay, I'll take the other guy from Toronto. Dave, what's wrong with this? All right. All right, Dave wants to answer. Okay, Dave, the other Dave. Okay, what's the answer?
It does not work on the database such a qualifier.
Okay, so let's look at the SQL. So tell me, what's wrong with the SQL? This is the SQL that it produces, and it's going to run, it's going to work. What's wrong with it? I've tested this. This is the SQL it produces. It doesn't produce an error, it executes. But I agree with you, there's something wrong with it. What's wrong with it? We're selecting everything from company. We're basically selecting company. We're interjoining on employee, right? We're matching the foreign key to the primary key, where the profession is a chef. What's wrong with that? Larry Mills. All right, I'll tell you. Okay, it works, but what happens in the case that we had the 3 computer scientists at Codemongers? If we had not searched for chef, if we had searched for chef, we'd just get one result back. But if we had searched for computer scientists, we would see Codemongers 3 times. Now, in case you don't see how that would happen, if we look at this, we're doing basically a Cartesian product on company and employee. And the employee is going to come up 3 times. We have 3 computer scientists at Codemongers. We're going to get Codemongers 3 times. Now, some of you might say, oh, heck, just put a distinct on it. Well, if that's the case, why doesn't Apple always put distincts on everything? Right? That should be the default. If we don't want to be surprised, why do we have to think about when we're going to use a distinct or not? I had the fortune or misfortune of once working for an online Yellow Pages. We did everything in SQL. We did Java server pages. And they made no qualms of letting me know that if you use a distinct in your code, they'll remove a testicle. But I had 2 from birth, so I'm okay. The reason why distincts are bad is because they essentially do a full table scan. We all know sometimes we need to use indexes so we can avoid full table scans. But if we have a distinct, you're basically throwing that out the window. You're essentially doing a full table scan. It really slows things down. And when you're looking, you're making your money, online Yellow Pages, 10 cents a click, you make your money in volume, and you can't have anything slowing you down. So that's why Apple doesn't turn on distinct by default. And to be honest, if you're using a distinct, you're covering something up. There's a code smell. 9 times out of 10, your SQL is doing something wrong. You shouldn't have to have a distinct. It's the same thing in Java, where if you use an instance of, right? If you have an animal that happens to be actually a dog, you just say, make noise, and it will bark. You shouldn't have to say, is this animal an instance of dog? Well, in that case, I want you to bark. That's code smell. It's the same thing with distinct. There's something going on here. So, where does that take us? Let's look at companies that have both a chef and a programmer. All right? So our first qualifier is the same as before, the chef qualifier. The computer scientist qualifier is almost the same, it's just we're looking for a computer scientist for the profession. We combine them with an and qualifier, and we say fetch. Farouk, what's wrong with this qualifier?
It's going to make the AND operation between the two qualifiers. And in both cases, we'll not be able to get any record. Yes.
Perfect. So let's look at the sequel. Oops, I hit too far. Companies with a chef and a coder. We're selecting everything from company, doing an inner join on employee, foreign key to primary key, where profession is both a chef and a computer scientist. That will never return results because you can't be both a chef and a computer scientist at the same time. What we really wanted was to find one person who was a chef and a different person who was a computer scientist. And if you look at the domain, this is basically a domain language or a proprietary way of connecting to an object database, if we want to think about it that way. We're looking at this. If we're not thinking about the sequel, we should expect to get the correct results. And we do if it's an array. Okay? But because we're actually hitting the database, it's never going to give us anything. So let's talk about in memory now. Here we have the chef qualifier, the computer scientist qualifier. We're doing an AND qualifier. Same qualifier. The only difference is now I'm taking a filtered array. I say all companies. I dump all of the companies into RAM, and now I do the qualifier. The guy with the turban raised his hand. What's your name?
I'm not raising my hand.
Can you tell me what's wrong with this qualifier? What am I doing wrong here? It's too small?
More than followers.
Well, the answer is there's nothing wrong with it. It's going to work. But what if you had 1 million companies, 19 million companies? Are you going to fault all of those into memory just to figure this out? Come on. I mean, we're using EOF. This was from the dawn of time. Somebody's had to think of this. Are we totally out of luck? There's got to be a way. But let me show you something before we go on. I have an app, and I'll show it to you later. It's on GitHub. You can download it. It's got the database. It's got everything. But all it does is it produces a static page like this. So if I do operator contains, that's an Apple thing. You say eoqualifier.operator contains, right? That's how Apple wants us to find the existence of something if you're trying to traverse it too many. If I look for companies with a chef, I get Joe's Crab Shack. Yeah, they got a chef. They're a restaurant. Codemongers, remember they hired that famous chef to keep the programmers working hard. Right? That makes sense. Companies with a computer scientist, we get codemongers 3 times. Companies with both a chef and a computer scientist, we get goose eggs. But come on, we know codemongers has some famous guy making their food, and they have several programmers on staff. So that's just wrong. We're hitting the database and we're getting wrong results. Now, if I take the same qualifier and I do it in memory, we get the right results for looking for a chef. We get the right results when we're looking for a computer scientist. We only get codemongers once. And if we're looking for both a computer scientist and a chef, we get codemongers. Using all Apple qualifiers. Everything's Apple. I'm not talking about exist qualifiers yet. Everything's Apple. This should make you queasy in the pants. This is scary stuff because if you see you're testing something, especially in early development, you look at companies with a chef, oh yeah, my qualifier works. And then you build up this page and your customers start looking for stuff and they start getting weird results. And how is this if we can say that we use the qualifier in memory in an NS array and we use it against a database? They should be the same thing. Now we can say, oh yeah, but we're mapping objects to something relational. There's got to be something lost in translation. But I don't fully buy that. We're better than that. We have EOF, right? We were here before anybody else. We're still standing. All right? Somebody has to figure this stuff out. Okay? Apple's operator contains will always execute. all right? It's very disconcerting that we get surprised, that we get one result when we do it in memory, and we get a different result when we do it in SQL. You don't know what's going to happen. You have to think about it. You think about it hard. Oh, maybe I need to put a distinct. Oh, maybe I need to do this. Oh, maybe it's not going to work at all. And if it's not going to work at all, what am I going to do to get those results? I really want to find the companies that have at least one computer scientist and one chef. If I told my client, I can't figure that out, they're like, well, who the hell are you? That's a simple question. You can't figure that out? You know, we can't admit that. We'll never admit that. Okay? We'll find a solution. That's what we do. We're solution providers. It doesn't matter what tools we use. We find solutions. We must have qualifiers that will work no matter the situation. No surprises. So this day forth, we now have 11th commandment to go above Chuck Hill's 10 commandments that thou shalt not use operator contains. There's no reason for it. We should all go home tonight, look at our code, and see where are we using operator contains and say, you know what? That crazy guy Aaron, he helped me find a bug today. We should all be scared and go look at that. We should not be using operator. There's no reason for it. An addendum to this, I know some of you guys are using front base. We've used front base too. Contains is a nebulous word. You know, you can almost say, does this string contain the substring star E star? Does all first names that have an E in there? You can almost see that. You know, if you're looking at strings in Java, there's a contains, right? Well, some people, they looked at that, and even though in EOF we have case and sensitive like, we have like, you know, we have all this kind of stuff. We also have operator contains. They looked at operator contains and said, you know what, that should be a like. And somebody, when they wrote the front base adapter, they made it so. Every time you use operator contains, I'm going to do a string comparison, right? And if that's you, you could go in there and you can, if you're using a modern front base adapter, you can use that property, front base contains operator fix, set it to true, and you can use contains the way Apple intended it to be used. But what are we going to do? We're not going to use it anymore. We're not going to use operator contains. It's too dangerous. So let's say that we take this example again, the chef and the coder, and we write it as an exist qualifier. This is how you break it down. You say new exist qualifier. And then down here, this is how my mind works. I quickly jump to the base key path. All right? This is how I hop over into the exist bridge. 9 times out of 10, I'm using it to solve a too many problem. So company.employees, that's a too many. Too manys are hard. I use that to hop over the chasm. And then in my subqualifier, this part here, everything is 2 ones. 2 ones are easy. So I'm jumping over to the employees bucket and I change my perspective. Now that I've jumped over, everything starts with employee. I want to find employees where the profession is chef. Computer scientists, I want to find employees where their profession is computer scientist. I combine them into an and qualifier, and I say fetch. This is what the SQL looked like. This is actual SQL. This is how it runs. We're selecting everything from company, and now there's no joins, which is kind of nice. Just give me the companies. Now, I understand for a lot of us, me included, when I first started looking at exists, I had to wrap my head around a little bit, but at least you can say I'm selecting companies where there exists, where there's an if condition that evaluates to true, where exists, kind of beautiful, where exists. And then we say we're selecting something from employee, we just need to select from employee where the profession is chef, and now we tie everything out to the back. So we say the company ID of the employee, the foreign key, is equal to T0 ID. T0 is what? T0 is company. That's where we tie the foreign key to the primary key, right there, the last thing inside the where. So it's totally separated. When you look at those exists brackets, it's kind of like in Java where you put the curly stuff. When you put the curly braces, that's like a new block of code. You can have new ivars, you can have new variables, and they don't interact with the rest of your code. You can make a new temporary variable. It's the same thing here. That exists will not cross-pollinate with the other exists. So we totally get what we want. All the companies that have both a computer scientist and a chef. What if I wanted to use it as an in? All I have to do is to pass a true-false as a third parameter. Uses in-qual instead, true or false. Same thing. That's all I have to change. But then what I get in SQL looks a little bit different. And to be honest, this is easier for most of us to grok. We understand this better because we're selecting from company where the company's primary key is in, and then we're selecting the foreign key from employee. We understand that better. That makes more sense to us, I think. It's easier to understand. All right? So, let me see. I have an example to show you. When I run the ERX exist qualifier, I get the same results from the database that I get in memory. As if I was doing it the Apple way. There's no surprises. I can use it either way. If I do it with an in clause where I convert it, I get the same results. Everything works. So now this asks the question, which is better, an exist qualifier or an in qualifier? And truthfully, the answer really should be, it doesn't matter. If it's as easy for someone like me to just give you a Boolean switch to make it an in or exist, it should be easy for Oracle or any other database vendor. SQL's been around since the dawn of time, right? They should automatically be able to look at it and rewrite it so that it performs better. Their optimizers should take care of that for us. Unfortunately, most optimizers don't take care of this. It's really sad. When somebody says, SQL Data's been around, they're old as time, they're understood, I say, well, if they're really so great, how come they can't do this by default? So the simple answer would be, exist is usually faster, but you need to test. Just test it. It's a Boolean switch. Run it twice. Which is faster? That's the simplest, we can all remember that. But if you really want to understand when to use which, and you want to be more proactive about it, when the subquery result set, the join of the subquery, when that result set is small, you should use an in. When the outer result set, the company in this case, if the company result set is small, you should use an exist. So in this example, you're going to have less companies than you have employees. Most companies are not employee of one. They usually have 10 employees, 500 employees. So whatever you have in the subqualifier is going to be bigger, right? There's going to be more objects in there. There's going to be less objects in the company table. That's why I say generally that's how that works. With the too many, you should generally use an exist. But this isn't always the case. And so here's an explanation. Let's look at how an exist qualifier is built. We say select everything from company where there exists an employee whose profession is chef. And then we join the foreign key at the bottom to the primary key of company. That's the actual SQL. But what is the pseudocode? What would Oracle, what would Frontbase actually do? This is pretty close to what Oracle would do. It says, for every X in the entire company table, it's going to do a full table scan of company. It can't be helped. You're trying to find all the companies where something exists. It has to go through every row of the company table. And for every X, it's going to do a quick if check. And for a particular company, once it finds the first one, it stops because it's an existence check. It finds one computer scientist, okay, I'm done. But then it has to do that for the next X. For the next company, it has to start over again. You're going to do a full table scan of company. So if company is huge, you may not want to use an exist. What about an in clause? We're selecting everything from company where the company's primary key is in. Now we're selecting just the foreign key of employee that points to company, where their profession is chef. Well, how does that execute? What would Oracle do with that? Here, we're selecting everything from company, T0, and then we're building a view on the time, a view on the fly, right? You see those brackets there? We're making a T1. We're basically selecting from employee, but we only care about the foreign key. And then we do an inner join, right? We see where T0 ID equals company ID, T1 company ID. But notice how I put a distinct in there. That's really what happens. It's going to put a distinct in there because if we're only selecting the foreign key, what happens if we don't have the distinct? If we don't have the distinct, we're going to get 3 values of code mongers again. It's the same problem we had before. So you have to have a distinct for the foreign key. We only want to see one of them, right? Because we're doing an inner join now. The where clause, that's the inner join. If we don't do a distinct, we're going to get too many results back. So it will always internally do a distinct. And if you've got a lot of stuff in that subquery, you do a distinct, you're basically doing a full table scan on those results, and you'll lose a testicle. All right, so that's the game you have to play. You have to look at it and you have to evaluate what's faster, but that gives you the science behind it. Now, Dave asked me a technical question. He says, every time I look at the SQL that's generated, I see the hand waving that's going on in the exist qualifier. I see it taking what Apple would normally have T0s, T1s, and the only thing I ever see it replacing is a T0. It always just replaces a T0. I always see an exist 0. I never see an exist 1 replacement. When does that happen? It happens when your subqualifier is complex, when you've got multiple joins. In this case, we want to find companies with a chef who has a salary between $20,000 and $40,000. And this time, instead of using the foreign key of chef, I go all the way to the profession table and look for the string CHEF, chef. Right? So we're going down here at the bottom, we're first jumping over the too many to employees. But then from the employee perspective, I want to find profession name is chef. And salary greater than 20 grand, salary also less than 20 grand, and go fetch. This is the SQL we get. Outside is still so simple. Just give me the companies. Where exists, select. We're going to do an inner join now. This is where you see, where you would have T0 and T1. They become exist 0, exist 1. And the more joins you have, the more replacements you're going to have. And originally, it only supported up to 3. We did up to 9. If we need more, we can always do more. We can extend it further. I told you earlier on that normally we're solving problems with too many relationships. But sometimes we can even use it for a 2-1 relationship. Well, what does it look like anyway? Well, here, let's make a new ER_EXIST qualifier, but this time I want to find all of the employees that are chefs. I don't want to think about companies. I just want to go right to the employees and give me the chefs. Okay? So I can say employee.profession. Well, profession's a 2-1, right? Profession's a 2-1 relationship. It still works. You can still do exist. It's not gonna have a problem with that. And then we say profession name is CHEF. All right, that's the subqualifier. What does it look like? We're selecting everything from employee. We're selecting the employees, where there exists. We're selecting from profession. We're looking for the name that is chef. And then at the very end, the final and, we tie profession back to employee. Foreign key, primary key relationship. It works. There's nothing wrong with it. It's just most of the time, 2-1s are so easy and they're performant, it's not an issue. Well, here's one time that we really had an issue. This is some actual code from our app. The part in green was our original qualifier. And in this app, what we have is a grab bag of questions. First name, last name. And the customers, they put these on forms, right? They always want to use the same first name question on every form. Makes sense, or why have to keep creating new questions? You have a grab bag of questions, use them. So what we have to do is for a particular form, we have to have a placed question. So we have a placed question EO. And then when someone actually fills out the form, there's a real answer. So if I wanted to find all of the answers for first name, I would say answer.placeQuestion, placeQuestion.question is first name. And it worked. But look down at the 3 stars, asterisks at the bottom. Our answer table has 19 million rows. Our place question table has 27,000, and our question table has only 2,000 rows. You first have to do a Cartesian product between 19 million rows and 27,000 records before you can even get to the part where you're looking at the particular question to whittle it down. And that hurts. That took us 10 seconds to execute. When we rewrote it as an exist qualifier, we say answer.placeQuestion. Again, a 2-1 relationship. Jumps us over the chasm. It removes a join. Then we just say where placeQuestion.question is first name. We went from 10-second execution to slightly under 1 second execution. Still not fast, but it was enough for the day, and we went on and we did our other thing. It gave us extra legs. Okay. So early on, I asked, have you ever tried to find a null too many? You want to test if a too many relationship is empty or not. How would you do this? There's no way to do it with the Apple tools. You just can't do it. If you try to do is not null, it doesn't make sense. It doesn't correlate. You only do that for 2-1 relationships. If we want to find all companies with at least one employee, all we have to do is follow the company.employees to jump over the chasm. And then we just say a true qualifier. Actually, we don't even have to say that. We can just say null. It won't matter. That gives us existence. That is the essence, right? That's an exist qualifier. What does it look like in code? This is what gets generated. We're selecting everything from company, where exists. We're selecting something from employee, where true is true for all of time. That was our true qualifier. If we had null, it would just be empty there. And then we're just tying back the foreign key of employee, company ID, back to company.primary key. That's how you can test to see if your too many relationship has something in it. What about if you want to see if it's null, if it's an empty relationship? All you have to do is wrap it with an ERX not qualifier or an Apple not qualifier. You just wrap it with a not qualifier. And what does that do? It just says where not exists. It's really simple. There's no problems. For too many relationships, exist is your friend. For slow 2-1 relationships, exist can help you there too. When you think you're stuck, when you think that you're not able to query the database, you're not able to get the results that you want, it's funny how this one little qualifier can get you out of a rut. As much as I say that this is cool and I use it weekly, every week, there's not a week that goes by I use this in some way, an exist qualifier. There will be a time when you say, damn it, I'm in some other kind of pickle and it's not going to get me out. But you know what? You can go and look at the exist qualifier because it does both sides of the fence. It shows you how to write a in-memory part. It shows you how to hit the database. And it's a complex example. You can also go to the Huda frameworks. 10 years ago when I first realized this issue, this guy has these open source frameworks, the Huda frameworks, H-O-U-D-A-H. They were pretty good too. He has exist qualifiers, he has other things. You kind of get an idea of how to write qualifiers. You may have to write your own. If it's really important to you and you want to be able to sometimes hit the NS array, sometimes hit the database, you want to think in objects and you don't want to have to write some custom SQL. Of course, you can still write raw rows for SQL or something like that to get the result you need. That's a one-time thing, but if you're doing it over and over again, maybe it's time that you get something like an exist qualifier for your particular situation. You can build it yourself. Then, if you think about it and you step back and you say, oh, this is just too painful. Why do I have to write an exist qualifier? Why do I have to do all this? We said at the beginning of this lecture that simplicity is good. What we're really dealing with is a impedance mismatch. Objects don't relate to relations. We can't do any better than what EOF gives us. I can't think of anything better. I can't think of how to improve that any better. except remove the mapping. If you remove the mapping, then it's just your objects all the time. Your objects get saved. You're not having to deal with Entity Modeler and the prototypes and all the different things. You're not having to, and people say, well, you might have to learn some kind of proprietary query language. Well, isn't that what we did already? We're already doing a proprietary query language. If it's so much easier to write and you can write things so quickly, why not? And you say, well, this client, he has crystal reports. That has to talk to SQL. Okay, I would even rather have a mapping from object to relational just so he could use his crystal reports. It's just another way to think about it. I don't want to harp on that too long, but the main thrust of this talk is to say exist can do a lot. It can bias a lot. It makes that illusion of objects that much stronger. There's no more special, there's many fewer special cases. We can still think in objects, hit the database, and not worry about it. So, like I said, we extended the exist qualifier. There's a pull request that's 2 years old. I'm hoping that because of this talk, people will be more likely to pull it. If not, you can make your own fork of Wonder and pull it. It's open. There's a GitHub where I actually have the sample application. You can see the code. You can run with it. There is this presentation is actually all JavaScript and HTML. It's not Keynote. So that URL right there is how you can actually view the presentation. The final URL is to the actual results of the running app if you wanted to see it. There's a few more things I wanted to show you there. Some of those other examples there, I didn't just make up the SQL, I actually ran them. Companies with employees that have salaries between 20 and 40K, get Joe's Crab Shack. Companies with chef salaries between 20 and 40K, chef salaries between 20 and 40K, still Joe's Crab Shack. But that's the one that would give you that extra join where you have not only an exist 0 but an exist 1. Companies with employee salaries between 70,000 and 120,000, you get code mongers, right? Because we make more than chefs, right? Not always, If you're Justin Wilson, he probably makes more than any of us did. He's not here anymore, but right? So if you look for all chefs using the 2-1, you'll find Tim Smith from Joe's Crab Shack and Justin Wilson from Codemongers. All computer scientists using the in clause, using the 2-1, you find these people. All companies with at least one employee, and then all companies with no employees, the thing that we could never do. And it's one of those newbie questions like, why can't I find an empty too many? You see it for many years, people say you can't do it. Well, if you use an exist, it's not that hard. So that's about all I have for the talk. I'm willing to entertain questions now and open the discussion up some.
Also, I've taken Aaron's exist qualifier, and I can send an email or whatever with there's another pull request on top of Aaron's exist qualifier that adds some additional keys to ERX key. So you can have a too-many relationship for employees dot exist or is empty. So you don't even have to figure out the exist qualifier itself. You can just say employees dot is empty or employees dot contains, what is it? It's like contains objects matching, and then you pass in a qualifier.
Excellent. Yeah. So it's a hard thing. We're all contributing code, and we don't want any of our code to break, right? And you don't know if you can trust this code. It's a difficult thing. We're all a community, right? But it can be tough. I know that there's other people that have had trouble getting their code committed, but we're all donating our time. It's all free, right? So it's a difficult thing. And I'm glad that this talk can raise our confidence a little bit. How many of you guys use the operator contains or have faced any of these kind of issues or tried to make a qualifier and realized that, hey, it's not working the way I thought, you weren't able to... Yeah. So, even if you use ERX exist qualifier already, if you get the new code, you can have a play with using the in version and see how the performance differs in parts of your code. It might be faster, it might be slower. Actually, for us, for our domain, most of the times we write the qualifier, the in is much more performant. That was part of the push for adding the in. In this particular example with companies' employees, exists is better, but for what the stuff we were doing, we had such bigger starting points that it made sense to use an in. So it would be fun for you guys to try that and see if you get better performance.
You mentioned that you fixed or worked on the long keypad, deep keypad. How did you do that?
Very good question. Dave and I worked on that one night together. And I said to him, well, he said to me, he said, look, I put in for the base, in all these examples, they were simple. The base key path was 1 hop. And he said, if I put in 2 hops, it breaks. I was like, yeah, I know that. I've experienced that before. But then I said to him, if you break it out and you nest it, if you do an exist qualifier inside of an exist qualifier, doing 1 hop at each stage, it works. You can nest the exists. And he's like, oh, okay. You're right, it works. But then he said, well, why don't we just use recursion on the inside to do that for you anyway? I was like, yeah. So whenever you have multiple hops, it just doesn't exist within it exists until it gets to the final part. And that's how it solves it.
Even in memory?
It works in memory as well, but there's a different path. When you write a qualifier, there's one path, there's one method for handling the SQL generation. There's another method for doing in-memory evaluation. And the in-memory part is just much more simple. And I don't remember if it's doing recursion there or not. It might also be doing recursion. But that code is much more easier to understand than the... There's a bit of hand-waving that happens in the SQL replacement, but the in-memory stuff is easier to follow. But it works in both.
Could you pull up the slide with the exists1 alias? I just wanted to add, you mentioned the full table risk involved. And I wanted to add that if you're using, at least with Oracle, and then I think also with PostgreSQL, if you have the case that the employee table is large, but you only have a few chefs, you can create an index that covers the profession ID and the company ID rows of that table, and then it will not even hit the table data at all. It just satisfies the subquery from the index data. It goes right into the index tree leaf and is done.
Excellent. So what you're saying is you made an index on 2 attributes together.
Yeah. Combined index, and then if the query can be satisfied with just the index data, it won't touch the table at all.
Beautiful. Beautiful. Maybe I spoke too fast. I don't have anything else to say. If you want to see something else, let me tell you a situation that happened just this past week, if you guys are interested. How much time do we have? We still have what? 15 minutes. All right, I'll set the stage for you. These forms that people fill out, there are deadlines. If you don't fill it out by Friday at midnight, it's too late. There's a deadline. But sometimes sometimes there's extenuating circumstances. You know, the group of kids, they were flying from somewhere, who knows what the issue is. Sometimes it's one person, sometimes it's a group of 10 people. We give them a deadline override. For you guys, you can do it 3 days past that. You can do it on Monday after the Friday. So we have a separate, you know, for the actual forms, there's an actual form deadline, but there's a deadline override table where we join up the form to a particular user. We give individual users overrides. As you can imagine, there's a time crunch. Everybody waits to the last minute. Almost all of us wait to the last minute to do our presentations, right? It's universal. Doesn't matter what you do in life, whenever there's a deadline, we always wait to the last minute. And it's the same with our clients. When people fill out these forms, there's a rush, okay? But they also need new features, they need different things, but they don't want to deploy a new version of the application when there's these deadlines fast approaching. And so they have to think about, okay, we want to fix a bug, or we want to do this or that. When are the deadlines? And it's kind of funny. You think we would have thought of this years ago, but it was just this last week or week before. We said, let's give them an interface where they can see the deadlines. And there's a couple ways you could attack this problem. You could fetch against the form table and find the general deadlines. And then you can do another fetch against the override table to get another set of deadlines. And then you can do all this work in Java to like put it together and try to figure out and make a display for the user where they see, oh, okay, April 1st, nothing's happened. April 2nd, April 3rd, there's 3 different types of forms that have deadlines on April 3rd. And we want to present this to them. But you can think about it. It's not that hard, I guess, to do 2 separate queries. You do a query against the form table to get the general deadlines, a query against the override table, get the override deadlines, put them together, but you're having to mash it up. There's some room for error there. Well, if you do an exist qualifier, you can just focus on the forms. You say, I want to find the forms that have deadlines at a specific time, and or you say or exists, jump over their too many relationship to the overrides. People that have specific overrides that fall within a particular April 3rd deadline. And so you're just only thinking about those forms. The forms are what you want to present to the user. You're not wanting to present to them all the different myriad people that, you just want to know, are there people that have deadlines on these dates? So we're able to just think about one EO with existence. Yeah, I don't know. If I didn't have this, I would have left web objects a long time ago. That's the truth. When I told you I cried the first time I realized the shortcomings of woe, it was the truth. I was living in Asia. I was doing driver development for Windows at the time. I was doing human facial recognition for a local company in Taiwan. When that company started losing contracts to American companies, I sat down and I looked at what I want to do with my life. I bought a copy of Woe, $700 or so, back in 2000. For 3 months, I just played with it. I said, this stuff is great. I'm able to, I buy into this whole object extraction thing. It makes sense. I love it. And then a few years later, I started finding these problems. I'm like, well, what the heck? I'm not expecting these kind of non-deterministic behavior. But at least we have the plumbing, right? Plumbing to think in different ways, and we have things like the exist qualifier that can make our life easier. But I haven't seen anything else like this. You know, we've talked about Cayenne in the past. It's almost as good, or maybe equally good. You know, there's nothing better. I haven't seen anything better as far as object to relational mapping. So that's why we're still here. And thank you for your time.